All right, everyone. Today we're going over 7.3 notes with simplifying, multiplying, and dividing rational expressions. Today you're going to be able to do that. So a little warm-up question right here. How do we simplify 10 and 24? Well, we're going to find a number they're both divisible by, which in this case would be 2. So we divide 10 by 2, which is 5, and we divide 24 by 2, which is 12. Okay. Now just a reminder, how do we multiply? Well, you multiply across, right? So 3 times 20, okay, and 5 times 9. All right, so again, 3 times 20 is 60. 5 times 9 will be 45. Now, can I simplify it any further? Absolutely. They're both divisible by 15. So that's going to be 4, and 45 divisible by 15 is 3. Okay. Now, how do we divide? Remember the rule keep, change, flip. We're keeping the first fraction, we're changing the sign from division to multiplication, and we're flipping 4 over 15 to 15 over 4 upside down. And now again we multiply across. So 2 times 15, it's going to be 30. And 5 times 4 is 20. And of course we can simplify them by dividing them by 10. So your final answer is 3 over 2. Now, yes, I know that we can also crisscross right here. 3 and 9. So you can simplify 3 and 9 right here for this. If we wanted to do it this way, we can also simplify 3 and 9 divisible by 3, and 20 and 5 divisible by 5. Okay? So we get 4 over 3. And we can do the same thing to the other one. So either or, okay? All right, so simplifying rational expressions, factor out the common factors in the numerator and denominator. If necessary, factor their expression top and bottom before crossing out common factors. So basically, you want to have everything simplified to a binomial. Okay. Now we have learned we had a review on factoring. So let's simplify the first example. I get 2x plus 3 times x minus 1 divided by 2. Now I'm going to write it out because not everybody remembers that square here means there's 2 of them. Does not mean I'm squaring the x and a 1. There's 2 the same factors, 2 the same parentheses that have x minus 1. So now I'm going to look at this example and I'm going to say, okay, is there anything that I can simplify it further? Meaning, do I have a greater common factor anywhere? All right, 2. Can I do a times c as to multiply a times c equals to b as a quadratic equation? No. Do I have a square root method here? No. So I can simply say that all of these factors are in the simplest form. Now, I am going to cancel out proportionally things that are alike on the top with things that are alike on the bottom, meaning the same factor on the top and the same factor on the bottom. I'm going to cross 1 x minus 1 and 1 x minus 1 proportionally. I know there's 2 of them here, but I cannot cross the second one. It's 1 to 1. Okay? Now, I don't have anything else on the top that is the same on the bottom. So, okay, so what I can do is just repeat what's left on the top and then repeat what's left on the bottom. Okay? And that is my answer. All right, pause that if you need to write that. All right, now in next example number 2, it's x squared plus 5x minus 6 over x squared minus 36. Okay, now again, learning from the factoring practice. 1, we always look for GCF. Okay, so if we have anything that belongs to both of those numbers, can we take it off? 2 situation, it's going to be when we have quadratic equation. Okay, and we are going to do first number times the last one equals the middle. So we do a times c has to equal to b. Then we also have third option when we have a leading coefficient, leading number in the front of the quadratic equation, where again, I'm just making it up, where again, we multiply first number times the last one. Okay, so a times c has to equal to middle number, which is b, but now our factors are going to have to divide it by that leading coefficient here, okay? And then for option, is when we have a a variable and then a number, which is a part of quadratic equation, right? Where we're going to use the square root method, okay? And usually the constant is a perfect square. All right, so how can we rewrite this fraction to have binomials, means factors with a single x's, so we can cancel something out. So on the top, we're going to do a times c, okay? We're going to multiply the first number 1 times -6, it's -6, and that has to equal to the middle number, which is 5. So two factors that multiply to -6 but add to 5, it's 1 and 6. And of course, 1 has to be negative to give me 5. So instead of x squared plus 5x minus 6, I'm going to write x minus 6 and x plus 5, which are two binomials, okay? Now on the bottom, I have option 4 right here, where I have a x squared and then a perfect square, where I can square root them. So I will square root them. I do not square the negative. Please do not confuse that with an I. We are only square rooting the 36. So square rooting x squared, it's simply an x in both parentheses. There's two of them because x times x, it's x squared. And then square rooting 36 is plus or minus 6. So I have plus 6 and minus 6, okay? Now, I have simplified the x squared plus 5x minus 6 and the x squared minus 36 to 4 different binomials. Now I am going to see what can I cancel from the top and the bottom that is the same. X minus 6 and x minus 6. So what is left? X plus 5 and x plus 6. And that is my final answer. Okay? All right. Now, just so you know, for both of these, I need to mention that you got to make sure that you set the bottom equal to 0. Why do we do that? Okay, and then solve. X cannot equal -6. Why? Because again, if I plug in -6 here instead of this x on the bottom, it's going to give me 0. And 0 will make this function undefined. So we got to make sure that we find what x values makes this function undefined, okay? Now the same thing for the first example, which I forgot to mention right here. Okay, we got to set x minus 1 equal to 0, x cannot equal 1. Why x cannot equal 1? Because right here, that's going to give me two zeros, and 2 times 0 is 0, and I cannot divide by 0. That's also called extraneous solutions, okay? So I just want you guys to know that. So anytime we have x on the bottom of the fraction, we got to make sure we equal it to 0. Make sure what is the value of x that we cannot plug in or we cannot have as a solution. Because if we do, it's going to give us a 0, which will make it a function undefined. All right, example 3, multiplication of rational functions. So again, we're going to multiply across. So I'm going to write it 3 times 4x cubed over 4x squared times 21. I'm simply going to multiply numbers with numbers. 3 times 4, it's 12x cubed. And 4 times 21, it's 84x squared. Now, remember that numbers go with numbers and variables like x's go with x's, z's go with z's, and y's go with y's, right? So we can simplify 12 and 84 divided by 12. So 12 by 12, it's 1. 84 by 12, it's 7. So let me rewrite that just to make it a step for those that, for those students that take a little bit more steps to understand. Okay, now, when we simplify in our x's, for those that understand where I'm coming from, 3x's on the top minus 2x's on the bottom will leave you with 1x on the top, okay? Because again, you're subtracting 3 minus 2 gives you with just an x, okay? Now, so this is 1 and this is not. Now, for those that don't understand what I just did, let me rewrite that. Okay, oops, it's cubed. Okay, If it makes it better for you and it helps you, I would suggest that you guys write 3x's. And you guys write 2x's. Okay? You got 2 here and 3 here. Now again, simplify and cancel the x by x. 1, 2, and there is not another one on the bottom to cancel. So what's left on the top? X over 7. Now pause that if you need to write it down. All right, now example 4. That's a little bit more difficult. So let's write it out because we got to make a few steps. And again, that's why factoring was very important. And if you're still not understanding factoring, please come and get help in one of our tutoring sessions because this is going to be very important. Okay. So x plus 4, it's a binomial. So we do not need to simplify it any further. So we got 2 quadratic equations, one on the top, one on the bottom, that we need to simplify. So this one has a leading coefficient 5. So I know when I multiply first number by the last one, which gives me negative 90, and it has to equal to 9, which is the middle number. I know that in the end, when I pick these factors, I got to divide them by 5. Okay? So it is going to be 15 and 6, I think. And of course, 6 has to be negative for it to become 9, right? 15 minus 6 gives me 9. So instead of this, I just had 2 factors instead. But remember that it's x plus 15 and x minus 6. And because I have a leading coefficient right here, 5, I got to divide each of these factors by 5. Now, 15 does divide by 5, which gives me 3. 6 does not divide by 5, so this 5 is going to be shoved in here in the front of that x. So as I'm rewriting it, now instead of this equation right here, I am putting x plus 3 now, which was divided by 5, the 15 by 5. And then the next factor is, 5x, not 3x, 5x. Okay, minus 6. Now, I like to put everything under one line. So I'm going to put this x plus 4 here, okay? Because again, this is all multiplication in between. So I'm going to put this x plus 4 at the end. Now on the bottom, I got x plus 4 as a factor. So I'm going to put it in parentheses. And now the same thing I'm going to do here. I'm going to multiply 3 times 3, which is 9. And it has to equal to 10, which is the middle number. 1 and 9. Okay, so again, these are going to be both positive. So this is going to be x plus 1 and x plus 9. And then again, remember, we have a leading coefficient here. Okay, leading coefficient of 3, which means, okay, I got to divide both of them by 3, and whatever is not divisible goes up front, in front of the x. So 9 divided by 3 is 3. Okay, and then this, it's not divisible. All right, so here I'm going to have 3x plus 1, and here I'm going to have x plus 3. Now, all of them are in binomial and in a factor form. So I'm going to start canceling things out. Whatever it's on the top and on the bottom, I'm going to cancel. So x plus 3 and x plus 3. X plus 4 and x plus 4. So I get 5x minus 6 over 3x plus 1. Now again, I do want to make sure that this x right here, what is the value of x that will make this function undefined? It will make it a 0, right? So 3x plus 1 equals 0. Okay, 3x equals negative 1. And, x, equals negative 1. And x cannot equal negative 1/3. Why? Because if I plug in 3 times negative 1/3 plus 1, these are going to cancel. This is going to become negative 1 plus 1, which will make it a 0. And I do not want to have a 0 here, okay? So that is for this function. Again, the same thing for the first function that we did here, which again, I forgot. Right here, 4x squared equals 0. Divided by 4, divided by 4, x cannot equal 0 at the end. Okay, so because if it does, then that's going to make this function undefined. Okay? All right, pause it if you need to write it down. All right, and the last example. you got 2x squared minus 3x minus 2 over 3x minus 6 times 6x 4x squared minus 1. Again, on the first one, we're going to put it all in one line. On the first one here, 2 times negative 2, it's negative 4, has to equal to negative 3. Two factors, it's 1 and 4, and 1 has, and 4 has to be negative, okay, to make it negative 3. So instead of this function, I will put x plus 1 and x minus 4, but then again, remember we got a 2 as a leading coefficient, so we're going to divide them both by 2. This is divisible, gives you negative 2. This is not divisible. So first factor is 2x plus 1, and the second factor is x minus 2 now, which is simplified. And of course, we're going to multiply it by 6x. Now on the bottom, this function right here, okay, this is 3x minus 6. All right, this is not a quadratic equation. This is a binomial. So I cannot take a square root or do a times c, but what I can do is take a greater common factor out. So what does 3x and negative 6 has in common? They have 3 in common. If I divide them both by 3, I have x minus 2 left. Okay, now function right here. Okay, again, that's a 4x squared minus 1. That is a quadratic equation that only has a and a c. So we can take a square root, 4x squared, and we can take a square root of 1. So we're going to get 2x, and we're going to get plus or minus 1. So we can take a square root right here if we want to. All right. So we're going to get 2x and 2x. Okay. And then plus 1 and minus 1. Now we're going to look what's on the top and what's on the bottom. That looks the same. 2x plus 1 and 2x plus 1. X minus 2 and x minus 2. Now, let me rewrite it again. For those that understand what I'm doing, you're going to be able to cancel other things out. But let me rewrite it. What's left on the top? 6x. What's left on the bottom? 3 times 2x minus 1. Now, can I cancel anything else out? Yes, I can. I can simplify 6 and a 3. Why? Because there is a multiplication there. Okay? You cannot simplify if there's addition and subtraction, but because those two multiply, 6 can be divided by 3, and 3 can be divided by 3. So that's going to give you 2 and a 1. Okay? All right. So what's left on the top? 2 times x over 2x minus 1. Okay? Now again, just to make sure that we know what value would make this function undefined, or what value it's an extraneous solution, means the ones that cannot be used. We're going to take 2x minus 1 and equal it to 0. We take the bottom right here, okay? So 2x equals 1. X cannot equal 1 half. Because if that equals 1 half, it is going to make it a 0 on the bottom. All right, so here's a you try. Again, you can pause it and try it first. But here we go. First on the top, I got 15x minus 30. That is not a quadratic equation. Quadratic has a square there. It does not. So all I can do is take a greater common factor out, which is going to be 15. What's left is going to be x minus 3. Okay. Then x plus 6 carries, because that's already binomial. Now on the bottom here, I'm going to do a times c. So negative 42, first number times the last number, has to equal to negative 1. So I have 7 and a 6. And 7 has to be negative. I don't have to divide it by anything because this is 1. So my two factors is x minus 7 and x plus 6. Okay? And then on the last one right here, I got 4x minus 8. Again, there is not a square root there. Or it's not a quadratic equation, so I can't square root it. So I can take a 4 out, which leaves me with x minus 2. Now I'm going to look what I can cancel. Okay? Oops, I'm so sorry. X and x plus 6. I made a mistake right here, guys. It's supposed to be 2. Okay. 30 divided by, negative 30 divided by 15 is 2. So x plus 6 and x plus 6 cancels. X minus 2 and x minus 2 cancels. Now, on the top, I got 15 left. On the bottom, I got x minus 7 times 4. Okay? So now again, we're going to take x. We cannot simplify it any further, so this is what it says. We're going to take x minus 7 equal to 0. X cannot equal 7 because that will make this a 0, and 4 times 0 will make it a 0. Okay? All right, pause it if you need to. All right. Next example 2, multiplication. On the top, okay, I got x squared minus 16. It is a quadratic equation, and it does only have an a and a c. So that means I can square root it and a perfect square. So that's going to give me x and an x, and square root of 16 is plus or minus 4. Okay, and then of course times x minus 3. Now on the bottom again, I do not have a x squared there. So that means the only thing I can do is take a greater common factor out, which would be 7. If I divide both of them by 7, that gives me 7 and x minus 3. And of course, x plus 4 carries over. So I can cancel x plus 4, x plus 4, x minus 3, x minus 3. What do I have left? X minus 4 over 7. All right, example 6, add division. So again, remember the rule, keep, change, flip. So what we're going to do is we're going to keep x squared over x plus 5. We're going to change the division to multiplication, and we're going to flip it. This should be x squared. Was a typo. 10 plus x plus 25. Divided by x squared plus 5x. Okay? So, x squared right here stays over x plus 5. Okay? Now, x squared plus 10x plus 25. 25, middle, it's 10, so 5 and 5. So my two factors are going to be x plus 5 and x plus 5. Okay? Now, on the bottom, I want you to pay a very quick attention to the bottom. Does it have an x squared? It does. Does it have only two variables or two parts of quadratic equation? Yes, it does. Can I square root it? No, I cannot, because x does not square root. You cannot square root x. You can only square root something that's squared. So the only thing I can do when I got two x's and one is a square and one is singular, I can take a greater common factor out. So I'm going to take x out of both, which leaves me with x plus 5. Now I'm going to cancel things that are alike. X plus 5, x plus 5, x plus 5, x plus 5. So what do I have at? X squared and x. Again, 2x's minus 1x leaves you with an x. Now, if you don't know that, again, I'm going to strongly suggest that instead of writing x squared over x, write 2x's over 1x, and then cancel one of them out. That leaves you with an x. Again, pause that if you need to. All right, number 7. Number 7, this line right here just means a division. So I'm going to rewrite number 7 so it looks a little bit better. Okay, so I got x squared minus 4x over x squared minus 8x plus 16 times, well, let me first write it in division. Okay, 12 over 2x minus 8. Okay, now I'm going to keep, change, flip. So I'm keeping x squared minus 4x over x squared minus 8x plus 16 times 2x minus 8 go on the top and 12 goes on the bottom. Okay, everybody with me? All right. Now again, I'm going to look at the first one. The first one has an x squared, but it has an x here. That means I cannot square root it. So I can take a greater common factor out, which is x, which leaves me with x minus 4. Now, up here, I have 2x minus 8. I do not have a quadratic equation with a square. So I am going to take a greater common factor out, which is just 2, which leaves me with x minus 4. On the bottom, okay, I have a times c method here. I got a quadratic, so 16 has to equal to negative 8. That's negative 4 and negative 4. So I got x minus 4 and x minus 4, and then a 12. So again, I'm going to cancel things out. So x minus 4 and x minus 4, x minus 4 and x minus 4. So again, I got x, I got a 2, and I got a 12. Can I simplify it in a further? Absolutely. 2 and 12 simplify to 1 and 6, so that's going to be x over 6. I can divide 2 by 2 and 12 by 2 and get x over 6. And then again, for this equation, and for the one right here, for number 6, I just want to make sure, so this would be your final answer. So if you need to pause it, write it down, please do so. Now we do not need to solve for undefined function right here. But here on the first example, what was, let me look up very quick, what was our answer? All right, so for this function right here, for number 7, we got to make sure that that we set the original function, which is 2 minus 8 equal to 0. So 2x equals 8. X cannot equal 4. And then, of course, the two factors, which was -4 and -4, also cannot equal 4. Right? Because if I plug in 4, I'll get a 0. Okay? All right. And then the last one right here. Again, keep, change, flip. So I'm going to flip it. Minus x minus 20, x plus 2, times x plus 2 over 4x minus 20. Okay? Now, this right here, we're going to do a times c. So the two factors are 5 and 4. And 5 has to be negative. Okay, to give me -1. On the other side right here, it's going to be x plus 2. Here we get x plus 2. And then, of course, right here, 4x minus 20, we are going to take 4 out. X minus 5. Okay? So now what cancels? X minus 5, x minus 5. X plus 2, x plus 2. So x plus 4 over 4. And again, just make sure that you know that x cannot equal 2. Okay? All right. Now, also, here, x cannot equal 5. How do I know that? 4x minus 20 equals 0. 4x equals 20. X cannot equal 5. Okay? All right. Pause that if you need to write that. All right, and the last example up here. I am going to just flip it. So this is 2x squared plus 4x over x squared minus 7x plus 10 times, now I'm flipping this bottom upside down, 3x squared minus 13x minus 10 over 3x squared plus 6x. Okay? So right here, I have a x squared, but I also have an x. So I have to take a greater common factor out, and that's going to be a 2 that's in both and an x. So 2x. Now what's left? X plus 2. Here, I'm going to multiply the first number times the last number, so that's -30 and -13. And this is going to be 2 and 15. Why is it not 10 and 3? It's because they would have to be both negative, and negative times negative will make this 30 a positive, and this 30 needs to be negative. So it has to be 2 and 15, and 15 has to be negative. Okay? But now remember that we have a 3 as a leading coefficient, so x plus 2 and x minus 15 divided by 3. 3 goes in here. So that means the first factor is 2x plus, 3x, I apologize, plus 2. And the second one, it's divisible, so that's x minus 5. Okay? Now on the bottom here, again, a times c. So we got 10 has to equal to 7, -7. So we got 2 and 5, and they both got to be negative. and then we have nothing to divide it by because the leading coefficient is 1. And up here, of course, we have an x squared and an x, so we cannot square with this function, so we have to take a greater common factor out, which is going to be 3 and an x, and that leaves us with x plus 2. So, what can I cancel? X plus 2 and x plus 2, x minus 5 and x minus 5. So, what is left before you see if you can cancel anything else? 2x times 3x plus 2 over 3x times x minus 2. All right. Now, can I cancel anything else? Yes, I can. I can cancel these x's, okay, because they are on the outside and there is a multiplication in between all of them. So what's left on the top? It's 2 times 3x plus 2. I do not cancel anything on the inside of the factors. And 3 times x minus 2, okay? Now, I am going to make a separate video for these and attach that as well on eClass. Okay?